Alright, ladies and gentlemen, today we do our last lesson on factoring these super fun trinomials, which I'm guessing you're sick of by now, the ones that have a coefficient before x squared and aren't just x squared. Now, one thing that I should talk about before we get going, actually, you know what? Let's just have you do these first two problems first. So I want you to do the first one by splitting the middle term, and the second one by the very similar box method. Pause and then come back. Okay, welcome back. So here, your target number was 18. We were looking for numbers that multiplied to 18 and add to 9. Those would be 6 and 3. Again, the order you put them in doesn't matter. I'm going to go 3 and then 6. Doesn't really matter. You'll get the same answer either way. So my GCF is x from the first two, and I'm left with 2x plus 3. My GCF for the second two is 3. I'm left with 2x plus 3. And luckily my parentheses match. So I get x plus 3 times 2x plus 3. Woo! Box method, very similar. We still need to find numbers that multiply to negative 12. Remember that counts as a negative 4 at the end there. And add to 4. Those numbers would be 6 and negative 2. Again, when I have a one positive and one negative, I like to put it first if I'm doing split the middle term. But I'm not, so it doesn't really matter at all what order I put them in. Put 3x squared here and negative 4 here, and you can put the other two, negative 2x and 6x, wherever you want. GCF of the first column is 3x. GCF of the second column is, well, they're both negative, so let's go negative 2. GCF over here is x. GCF over here is 2. So I get 3x minus 2 times x plus 2. Awesome. Now, what I was going to mention at the beginning that I decided to wait for was this. The reason I like these two methods is twofold. One, it's a direct process. You can follow it every single time and get yourself to an answer. It's helpful for when problems are tough. Two, if you can't find any numbers that multiply to this and add to this, it means either you're not very good at finding numbers, which I'm hoping is not the case, or it could mean that the polynomial is prime. Now, we haven't really talked a lot about prime yet, if at all. Prime polynomials are ones that you can't factor at all. Okay, just like a prime number has factors of only one in itself, it's the same thing with prime polynomials. The only way you'd be able to factor them is to factor out a GCF of 1, which you just don't do unless it's part of the splitting the middle term process. So for example, let me quickly show you an example of one that would be prime. 2x squared, I'm going to stick a plus 9 at the end, plus, let's go with 12x in the middle. This one's definitely going to be prime. We're going to look for numbers that multiply to 18 and add to 12. Since I'm not thinking of any right off the bat, I'm going to list out all my factors of 18. 1 and 18, 2 and 9, 3 and 6. Since none of these numbers also add to 12, this polynomial is prime. Woohoo! That's why I like this method, because it's much easier to tell when a polynomial is prime. Even if you're making a big list of factors, even if this list was really large here, as long as none of them made this number, you'd be fine. Okay? That's why I like this method. However, the problem with both of these methods is that they're slow, because they actually take some time. There can be a potentially faster way to do it, and actually it's called guess and check. Sometimes mathematicians like to call guess and check brute force, basically where you try to figure it out. So here's how the brute force method works. Now this works best on polynomials where that leading coefficient and that final coefficient there are relatively easy numbers with few factors. Okay, the reason this works so well is because here's what you're going to do. You're basically just going to make two sets of parentheses. And first thing you're going to do is try to figure out, well, what are my signs going to be? I have a negative 4 at the end, so one's going to be positive and one's going to be negative. Okay, I don't really know which one right now. And I know that since I'm starting with 3x squared, this one's a pretty easy one. One of these has to start with 3x, one of them has to start with x. Now what you're going to do is you're just going to start trying numbers here. And those two numbers need to multiply to -4 because they are going to create the last number. And then all you have to do is just kind of mentally check that that middle coefficient. So here's how this works. I put a 4 here, I put a 1 here. Okay? And now I check. I know my first term and my last term work out, so I just got to check my middle two, the ones that are going to make x's. With these two, I get a -3x. With these two, I get a 4x. Those don't make -11x. I'm going to switch them up. I'm going to change this one to 4 and this one to 1. This is why a pencil will be really helpful here. These two multiply to -12. These two multiply to 1. -12 and 1 make -11. Boom, I'm done. So you don't need to check the first two. Okay, you don't need to check that this is 3x squared minus 12x plus x minus 4. You just need to check these two when you multiply them and these two when you multiply them to make sure you get the middle. Because you should only be trying things here and here that make 3x squared and that make -4. Okay, so this can be a potentially faster way of doing things, especially if you can do quick and easy math in your head. Now, this one's going to be a little bit more challenging because we start with a 10x squared. So we don't know if we're going 5 and 2 or 10 and 1. Now, since my numbers seem kind of reasonable, like I don't have any exceptionally large numbers in here, I'm going to guess I'm starting with 5 and 2, but that's honestly just a guess. I don't remember what this answer is. On the plus side, I know that since everything's positive, that I have two plus signs in my parentheses. Okay, so I'm just going to start trying some things. I'm going to write numbers above here because I don't have an eraser. So let's see what 3 and 2. Oh, 3 and 2 is a bad guess. Because if I put a 2 in here, these two have a greatest common factor of 2, and there was no greatest common factor to begin with. Once we get into factoring with greatest common factor, I'll explain in a little more detail why that doesn't make sense. But for right now, if your original expression doesn't have a GCF, which these don't, your final answer shouldn't have any individual parentheses with a GCF. So that has to be wrong. Let's try 2 and 3. 15 and 4. Hey, 15 and 4 make 19. I guessed right on the first try. Look at that. So that's a 2, that's a 3, and we're done. See, the brute force method can be really, really great if you are a good guesser. And once you kind of start recognizing patterns, if the numbers are easy, maybe that's the fastest way for you to go. Again, I think these are good methods to fall on. So I know I'm making this movie a little bit longer than it needs to be, but let me just say this. When you're factoring trinomials like this, my suggestion is that you get good at one of these two methods, okay, because you need one of those two methods in your back pocket for when you get stuck, and that you also really practice using the brute force method, especially when you're starting with stuff that's really easy, like if you got a 3x or a 5x, some kind of prime number that you're starting with and you can immediately put in what your first little bits are. It may be easiest just to go about guess and check. Okay, but you need to do whatever's going to allow you to go the fastest. Okay, so that's it for this video. Hope you learned something. Try the practice problems only using guess and check.